Hello, Algebra 1 students. It's Monday, May 4th. That's where we are. Can you believe it already?
May the force be with you.
May the 4th be with you. Isn't that funny? That's good. I hope you're having a great day. We have a short lesson today. We're not going to do, we're only going to do part of lesson 12.6. So let's say a prayer and get started. Father in heaven, I just thank you so much for this day, for your goodness and grace. I pray for all of my students that you would help them to focus, to understand, to learn this material so they have great success. And you would strengthen me and help me to be the very best teacher I can be, using words that will help them the most. In Jesus' name, amen. Okay, so let's get started. Here is the overhead, and this is lesson 12.6, okay, and this is called adding and subtracting rational expressions. Okay, so we've done the multiplying and the dividing, and so today we're going to do some adding and subtracting. Okay, so here's number one. The directions are add or subtract. And here we go, 5 over 3x plus 7 over 3x. Okay, so we have fractions again, right? And what do we do when we're adding fractions? We have to have the same denominator in order to add them. Now, do we have the same denominator? Yes, they all start out easy, right? We always do the easy ones. So we're going to add across and get 12 over 3x, okay? And that's it. Now you can reduce that to 4 over x, but basically the most important thing is that you know that the denominators are the same. You don't add them together, just like if we had 1/4 plus 2/4, that's 3/4. The 4 stays the same, it doesn't change. Okay, so that's a pretty easy one. Now, even though this looks a little harder, it really isn't. So this time I'm going to subtract 3x minus x plus 5 over x plus 1. X minus 1, sorry. So, of course, the first thing we look at is, do we have the same denominators? And the answer is yes. So really what I'm going to do is I'm going to take 3x and I'm going to subtract both of these things. Okay? So I need to put it in parentheses so that I make sure that I subtract both the x and the 5. Okay? So this comes out of here, this like having a positive 1 there, a 1 that I don't see, and it actually changes to negative because of the minus. So then I have negative 1 times x is minus x, and negative 1 times 5 is minus 5, and that's all over x minus 1. Okay, so you can see that I'm subtracting both of those terms. So now I see if I have any like terms I can combine. And of course, I can combine 3x minus x. So that becomes 2x minus 5 over x minus 1. Now remember, when we are simplifying, you cannot cross out your x's here because I have a minus between the two terms. It's not multiplication and it's not division. So be very careful. You are finished. This is the answer. Okay? Now my 5 is all whacked. There we go. Okay. All right, let's do the next one. Now, we're preparing for doing fractions that are different denominators, but we're going to do that tomorrow. So the first thing we're going to do is find the least common denominator of rational expressions, LCD. So if I did want to add or subtract them, I need to have a common denominator. So let's look at these two terms. 1 over 4r and r plus 3 over 10r squared. Okay, so what do I have here? I've got 4r and I have 10r squared. And you can do this two ways. I'm going to show you both ways. Some of you like to have a more concrete step-by-step, detail-oriented solution, and others of you that are that this kind of, you can see it kind of, you can reason your way through it. So I'm going to show you both. Okay? So if I was going to factor 4r down to prime numbers, it would be 2 times 2 times 4. So I have my prime factorization here. This is in order to find the least common denominator, okay? And if I was going to find the prime factors of 10r squared, that would be 2 times 5 times r, wouldn't it? If I multiplied all four of those things together, I would get 10r squared again. And they are completely factored down to prime factors. Okay, so what I do is I'm going to circle the things that are the same. So right here, they both have a 2, and they both have an r. So in order to find the LCD, least common denominator, I am going to use the circled factors once, and the other factors also once. Okay, now that sounds kind of strange, but you have this 2 here and you have this 2 there. So actually, that's 2 2's, isn't it? I'm only going to use one of them. I have 2 r's here, right, that are circled. In my least common denominator, I only use one of those circled r's. So to get the LCD, I'm going to take 2 times, now I have this 2 that's not circled, and I have a 5 that's not circled. So I only use the circled one once, and then I'm going to use that r once, and then the r outside. Okay? And if I multiply those all together, I get 20r squared. So the smallest thing, the least common denominator of 4r and 10r squared is 20r squared. Now, that is the very specific way to go about it. Now, you can look at this just to confirm. And you can say, okay, well, 4 and 10, what is the smallest number both 4 and 10 go into? Okay, well, 4 doesn't go into 10, but what's the next factor of 10? It's 20. So does 4 go into 20? Yes. So 20 is the smallest thing that 4 and 10 both go into. And then you say, what is the smallest variable both r and r squared go into? So again, the question is, what's the smallest number of r's that they both can have? Well, they can both go into. R has just r. You can have as many r's as you want. R squared, the smallest number I have is 2 there. So I have to have at least 2 to be able to say that the r and the r squared go into it. So when I combine 20 and r squared, there we get it, and it's the same as this. So that's 2 ways. You can reason your way through it using your brain, just your thinking, and you can also write it out using prime factorizations. We have both. Okay, so let's do another one. Here's B. We want to find the least common denominator of 5 over x minus 3 squared and x squared minus x minus 6. Of course we have to move on to harder things. Of course. Okay, so let's factor these. If I have x minus 3 squared, if I was to factor that, it would be x minus 3 times x minus 3, right? Okay, now if I had x squared minus x minus 6, how do I factor that? Well, I use magic X. This comes back a lot. I hope you know how to do it. Most of you did well on your Chapter 9 test, so you should be fine. Okay, so what multiplies to be negative 6 and adds to be negative 1? Negative 3 and 2. So I'm going to write x minus 3 times x plus 2. Okay, so the least common denominator means what is the smallest expression that will include all the parts of both denominators, okay? So I'm looking here and I'm saying, all right, I've got 2x minus 3's there. So whatever my answer is, I have to have at least 2 of those. And I'm looking at the second one and I'm saying, okay, I've got an x minus 3, but I also have an x plus 2. So whatever the least common denominator is in both, I have to have that x plus 2 also. So where they overlap is this right here, right? They both have 1. So I don't have to write it 3 times, but I do need to write it twice. Okay, the reason why I need 2 x minus 3's is that this first term has 2 of them. The second one only has 1, but it doesn't matter. The least common denominator is like a common thing. All the factors of both have to be included, okay? So this one up here has 2 of those, so my least common denominator has to have 2. In the same way, down here, this one has 1x plus 2. Well, the top one doesn't, but I have to have that represented down here. So this would be my answer. Okay, let's do another one. 3 over c minus 2 and c plus 8 over 2c plus 7. Okay. So let's see, the first thing I have is c minus 2. Well, I can't factor that like I did up above. So that's just one of them. And then this one, 2c plus 7, I can't factor that either because that's as simple as it's going to be. So I just need to include, and they're both different. So this one is definitely different than this one, so my least common denominator is both of them multiplied together. All right, I want you to do some OYOs now. So here we go. Number 1, add or subtract. And we have A 2 over y plus 1 over y. And then b 2x minus 1 minus 2x minus 3 over 2x minus 1. Okay, those are our adding and subtracting. And then number 2, I want you to find the LCD, the least common denominator. And here's A. 2 over x squared plus 4x minus 5, and x squared plus 2 over x squared plus 7x plus 10. All right, and then for b, 1 over 28m and m plus 1 over 7m cubed. Okay, so go ahead, after you've written those down, write them down and do those, pause the video, and we'll come back in just a minute and finish up. Okay. I'm going to change colors. Okay, let's go over these. So, do they have the same denominator? Yes, they do. So I'm just going to put 2 plus y plus 1 over the same denominator. I want you to put this step on your work. I want to see what you did. The more work you can show me, the better you will do. And then I combine like terms and I get this. And that is my answer. That is it. Make sure you do not cross out the y's. You cannot do that. I've got a plus here. I'm done. It's finished. Okay, I can't cross those out. So that's my answer. Okay, over here, let's put everything on top. And I'm going to subtract all of this. And my denominator is the same. So now I'm subtracting this whole thing, the binomial, that whole phrase. So I'm going to put a 1 here. So I'm going to distribute. So I have 4x plus 1. And then negative 1 times 2x is negative 2x. And negative 1 times negative 3 is positive 3. Okay. And when I combine like terms, I get 2x plus 4 over 2x minus 1. And that's it. And again, I absolutely cannot cross out the 2 x's because I have a plus and I have a minus here. If either one of them or both of them are added or subtracted, you can't cancel it out. It changes the answer because of the plus. I think we went over that on another lesson. I showed you an example, but that is just something that you have to remember. Okay? Don't cancel 2 x's. Okay? All right, let's go down here. Find the LCD. Excuse me. Okay. So I'm going to factor these, and I get x minus 5 and x minus 1. And I'm going to factor the other one, and that's, x plus 5, x plus 5, and x plus 2. Okay, so what would the LCD be? Well, they already both have an x plus 5, so I only need one of those. And this term has an x minus 1, so I'm going to add that in, or multiply that. And then here I have an x plus 2. That's it. Okay, on to the last one. Let's do the, I'll do both ways. So the prime factorization one. So 28m, those factors are 2 times 2 times 7 times m, right? And then 7m cubed would be 7 and then 3m's, right? Okay, so I circle what they have in common. And then this method is especially helpful when you have larger numbers. But it really works for this too, and step by step it works every time. Okay, so I write everything down once that's not circled. And now, instead of having 2 7s, I'm going to write 1 7. instead of having both m's, I'm going to write just one because they share it. So I end up with 28m cubed. And that's it. So that is the LCD. Now if we do it the other way, you can say, what does 28 and 7 both go into? Well, 7 goes into 28, so that works. Okay? Then what does, I've got 1m and m cubed both go into? Well, you can have as many m's as you want for m, but for m cubed I have at least 3. So the smallest number of m's that I can have for both of them would be m cubed. Okay, so then I put those together and I get m cubed. So you can talk your way through it this way. I'm just telling you, you do also need to know this way because it will get harder, the numbers will get bigger, and it won't be so obvious to see. Okay, that's our lesson for today, and I will send the homework home, and I hope you have a great Monday. Bye now.